Hi everyone, welcome to this channel. My name is Benedict Bali, and in this video I'm gonna talk about high performance computer graphics, specifically OpenGL and WebGL. This video has three parts. First, I'm gonna talk about some computer graphics basics, and then I'm gonna talk about OpenGL and WebGL. And at the end, there is a demo. So let's get started. There are some concepts in computer graphics. The first one I'd like to cover is geometry. As you know, computer graphics is all about geometry and everything related to geometry. So, not surprisingly, we have some geometric primitives like point, line, curve, polyline, polygon, cube, sphere, torus, cylinder, and so on. The important thing to note in here is vertex. What is vertex? A vertex is a data structure that describes some attributes like the position of a point in a 2D or 3D space or multiple points on a surface. The second concept is rasterization. Rasterization simply means converting a vector or high quality image to a raster or low quality image. In other words, rasterization is the process of converting shapes to pixels. For example, look at these images and their sizes. The vector image is beautiful and high resolution, and the raster image is ugly and low resolution. However, rasterization of 3D images is a little bit different. Rasterization is one of the typical techniques of rendering 3D models. In a 3D space, rasterization is converting primitives, which are connected vertices, to a set of fragments. And fragments are the data to generate a set of pixels in a frame buffer. Those fragments, which are 3D projections of the 2D pixels, are aligned to the pixel grid. So eventually they can be printed out as pixels on a 2D screen display. The next important concepts are tessellation and subdivision. In computer graphics, tessellation refers to the dividing of datasets of polygons or vertex sets presenting objects in a scene into suitable structure for rendering. Especially for real-time rendering, data is tessellated to triangles. By the way, tessellation can be also used for implementing subdivision surfaces. A subdivision surface is a curved surface represented by the specification of a polygonal mesh and produced by a recursive algorithmic method. A polygon mesh is a collection of vertices, edges, and faces. The other important concepts are Shading and shaders. Shading refers to the process of altering the color of an object or surface or polygon in the 3D scene based on things like the surface's angle to lights, its distance from lights, its angle to the camera and material properties, things like that. A shader is a type of computer program used for shading in 3D scenes, specifically the production of appropriate levels of light, darkness, and color in a rendered image. Most shaders are coded for and run on a GPU. Shading languages are used to program the GPU's rendering pipeline, which I will cover in this session. There are three types of shaders in common use: fragment shaders, geometry shaders, and vertex shaders. Compute shaders, tessellation shaders, and ray tracing shaders are recently added. And rendering. Rendering is the process of generating a photorealistic or non-photorealistic image from a 2D or 3D model. Okay, now we can understand what's going on in a rendering pipeline. Rendering pipeline is the process by which images are prepared and output onto the screen. The graphics rendering pipeline takes the 3D objects built from primitives described using vertices, applied processing, and calculates the fragments and renders them onto the 2D screen as pixels. We're gonna learn more about rendering pipeline in this session. Okay, we discovered the computer graphics concepts, and now it's time to understand what OpenGL is and what it does and how it works. OpenGL is a cross-language, cross-platform API for rendering 2D and 3D vector graphics. We use OpenGL for GPU-based applications like video games, virtual reality applications, scientific visualizations, and 3D modeling, CAD softwares, 3D animations, and so on. It's founded by Silicon Graphics and now is developed by Kronos Group. It's not open source, but we can use Mesa 3D. It's an open source implementation of OpenGL. It's free, but only for developers. Okay, so how it works? How OpenGL works? As you can see, this is typical application OpenGL OS interaction diagram. In here we see the interaction between application and OpenGL API and windowing API and Glue, something called Glue. Glue is a cross-platform open source C++, C++ extension loading library, and we can see interactions between OpenGL API and hardware, OpenGL drivers, and things like that. And in here we see rendering pipeline structure for a typical application, but in here we have OpenGL rendering pipeline, and this seems pretty much familiar with for us. So, by the way, the shader stages are programmable. So, we have we we can program vertex shaders, tessellations, geometry shaders, and fragment shaders with OpenGL API. Okay, so we have two ways to develop OpenGL apps or OpenGL softwares, OpenGL based softwares. We have the hard way and the easy way. The hard way is using C or C++ based applications because OpenGL is written in um, C or C++ language. We can do more, but it's pretty much difficult for us. And either we can use the hard way and or the easy way. The easy way is using OpenGL language bindings. We can use Java bindings, Python bindings, JavaScript bindings, and C Sharp bindings. Like I said, OpenGL language bindings are for pretty much every language we can use. We can use Java bindings like Java OpenGL or Juggle or lightweight Java game library. We can use Python bindings, for example, Python OpenGL or modern OpenGL, and so on. Okay, so we know how OpenGL works, but how we can use OpenGL? We can use OpenGL with OpenGL API. To use OpenGL API, however, we need to know everything about OpenGL shading language or GLSL. GLSL is a C style language with some C++ features. It's strongly typed and shaders are written in GLSL, and because of that, shaders stages are programmable. As you can see, we have shader stages and the implementation of them in GLSL. So we can use GL vertex shader for implementing vertex shader in GLSL and so on. Okay, what about WebGL? WebGL is a cross-browser, cross-platform JavaScript API for rendering 2D and 3D vector graphics. It's based on we use WebGL for GPU-based web applications in browsers, and it's founded by Mozilla Foundation, and it's developed by Coronas Group. Okay, so how WebGL works? WebGL works like OpenGL with some differences because everything happens in the browser. So, regardless of what operating system we use, the result is the same. Okay, like I said, there's a demo I want to show you. This demo is a simple OpenGL app, and it's written in C language in Windows. Let's see what we got in here. This is two libraries that we should use in Windows for OpenGL apps. This is where the vertex shader is defined. This is where the fragment shader is defined. And I'm not gonna explain everything, and so you should learn more about GLSL by yourself. Let's try it. Let's run this code. Let's see what happens. So this is a demo. I hope you enjoyed this session. Thanks for watching.